Ready when you are.
All right, wonderful. Well, thanks everybody for joining. My name is Trevor Bruner. I'm going to be giving a quick start guide onto working with engineers. If you're starting off in product, this is a great topic for you. And if you're a more experienced in product, you probably know most of these things, even if you don't know that you know them. And so please join the Orange channel in Slack and we can continue that conversation there. And this quick start guide for working with engineers is part of a larger effort that I'm working on. So if you're interested in learning more, please reach out and let me know. I'm happy to share that information with you. So first, I'd like to thank our sponsors, without which this event wouldn't be happening. So thank you. So I'd like to start with why. Perhaps this is my homage to Simon Sinek, but why me? Why this topic? And then what will you learn after this thing is over with? So first, why me? I elbowed my way into product management. I had no experience. I barely understood what the job was, and so I made all the mistakes. I have learned from them. I now have product reporting to me. I also have engineers reporting up to me. And so maybe in a few years, I'll come back with a quick start guide to managing engineers, but until that point. And to be tongue in cheek, why should you listen to me? Oh, I'm here. So there's probably better information out there, but for the next 20 minutes, let's do the best what we can. So let's assume that product management is like a car. I think in analogies, and so forgive me for that. But there's an amazing amount of information out there about how do I get into product management. That's for people looking for the keys of how do I get in the car. There's also an amazing amount of information out there on how do I prioritize, how do I craft a vision, how do I get buy-in. That's learning how to see the road and the terrain when you're driving the car. But if you don't know how to effectively work with engineers, you're trying to drive the car without an engine. Engineers are the motive force that propels your product forward. If you can't get them on your side, or if you interfere with their productivity, it won't matter how great your product vision is or your roadmaps are, you'll never get off the starting blocks. So what will you learn here? Well, first, engineers are just like you, but different. And second, I hope you'll learn how to craft great working relationships where you can respect those differences and use them to your advantage. And finally, you'll learn who the most important person is in your company. And it's not your boss, and it's not your CEO. So let's go to the topics. So the different topics we'll cover today are relativity, problems over solutions. This applies to engineers and to customers. Who that most important person is, how to help engineers with the Goldilocks problem, and finally, it's not all features. And the sooner you learn this, the better you'll be able to work with engineers, and you'll also just be a better product manager in general. So first things first, time is relative. You are a hummingbird. Your engineers are elephants. You can quickly flit here and there and change directions in the blink of an eye. Engineers are able to move heavy things long distances, but if you ask them to change directions, it takes them time to put down their mental load, shift, and pick up that new mental load. And to you, engineers may look slow and plodding, but to them, you have the attention span of a 3-year-old after a couple shots of espresso. Both of these personality traits are needed, but if you ask an elephant to change directions as quickly as a hummingbird, you're gonna be sorely disappointed. Similarly, if you ask a hummingbird to lift what an elephant can carry, you'll be just as disappointed. The take-home message here is that you have a dozen blocks of time during the day. You may be on back-to-back 30-minute calls for 6 straight hours. Engineers have 2, maybe 3 blocks of time during their day. That means that one short 30-minute meeting between you and an engineer can destroy an entire morning's productivity for them. That 30 minutes may fall in the middle of their productive block of time, and now that block is simply gone. So be careful about those quick calls with engineers. They may cost you more than you realize. And finally, this is the world of relativity. Here's the chart of engineers' ability to deliver, i.e. the productivity, and the likelihood of them getting the right thing out the door as they spend more time with you. If you never talk to engineers, if they never spend time talking to you, then they may be super productive. They can build stuff all day long, but they're unlikely to build the right thing. And if they're always talking with you, they may know exactly what to build and have all the context in the world, but never actually have time to build it. So please respect your engineer's time and understand that your understanding of time is different from theirs. Second, bring problems, not solutions. So often we start by telling engineers what to build instead of the problems to solve. And so here's an example. Let's say you go to the doctor with a pain in your leg. You say, give me Percocet and a cast. You're being prescriptive, and that's not good. Next level up, you can say, doc, I think I broke my leg. better, but it's still being assumptive, unless you actually have like a second knee or see the bone sticking out. Better still is I fell down the stairs last night. I heard a crack. I can't put weight on it. And now you're being descriptive. You're describing the problem and you're letting the doctor do their thing and diagnose and prescribe. And the best thing you can do is say, Doc, I want to run a marathon and hike Mount Everest. Can you help me? And now you're focusing on the real outcome that you want and letting the physician figure out how to heal you, but not only heal you, but make you better. It's the same with engineers. You want to give them the outcome you want to achieve, not prescribe the solution. And so doing it the right way may take longer in the short term, but you'll get better outcomes and actually get take advantage of all the smarts the engineers have. By helping them, by giving them the solution, cuts them off at the knees and turns them into ticket takers. So as a real world example, one of my products uses a whole bunch of API calls and customers are complaining. And so if I come to the engineers and say, how do I reduce the number of API calls? It's probably the wrong answer. You can say, how do I prevent my customers from experiencing server overloads and complaining to us? That's the objective we want to have. Another example you probably heard about, loading screens take too long to load. So if we come to the engineers and say, you should implement lazy loading, that's the wrong way to approach the problem. That's very prescriptive. So how about an outcome of reduce the percentage of paid bounces to 1%? What could that result in? Or let them figure out, is there a way to change the order of the calls? Or maybe they need to add a pop-up to distract them. There's a real world example of airline passengers being unhappy about the wait time at the baggage carousel. So instead of making the time faster to look at the bags there, the airport just put the terminals further from the baggage carousels and made people walk further so that their bags were actually there. Again, perhaps a bit of an anti-pattern, but it was the objective needed, which was fewer customer complaints. And the thing is, this is the right way to work with engineers, because this is exactly how you want customers to work with you. And so this is what I mean by engineers are just like you. They want to solve problems. So let them. So number 3, who is that most mysterious, most important person in your company? And I should pause to say, this is the most important person to your success. It's the person who's most responsible for you being a great product manager early in your career. And the answer is, it's your engineering manager. A good engineering manager is a mentor to you. They're a coach to the team members. They're someone who can translate product management speak to engineers, and then engineering speak back to you. They can schedule work. They're a delegator of work. They know what everyone on the team is working on and what they're good at. And a good engineering manager is worth their weight in gold. So get close to your engineering manager. Get in the way, ask questions. Engineering managers are much more like hummingbirds than they are like elephants. If you have a problem, reach out to your engineering manager. If something doesn't make sense, don't go to the hands-on keyboards engineer. Go to the engineering manager. They are there to teach you. And then on this graph here, the drop off on the right is when you're just spending so much time with them that you're actually not doing anything else. So bias towards spending more time with your engineering manager and getting very, very close to that person. They will make your life much, much better. Number 4, your challenge is to help your team put the right effort into the right problems at the right time. I think of this as the Goldilocks problem. Not too hot, not too cold, not too big, not too small, not too hard, not too soft, but just right. If you tell your team to go dig a hole, they'll have no idea if they need a shovel or an excavator. You've given them the what, or you dig the hole, but you've not given them the why. So one tool is fast, doesn't take any training, but it doesn't really scale very well. The other tool requires training and is expensive. But if you need to dig the foundation of a skyscraper, it's the only way to go. So how do you help the team know which tool to use? And it's all about the context. This goes back to the doctor analogy. Why do we need the hole? What's the problem we're trying to solve? What's the behavior we want to encourage? How many people is this for? How long do we have before the hole is needed? If I need the hole tomorrow, I don't have time to rent an excavator. Is this a one-time thing, or we need the solution again and again and again at massive scale? So once you give that context, your team will know which tool is the right one to use for the job at hand, and then trust them to know which one to use. So again, I think we have to have an XKCD in just about every presentation that I do here, but So when you look at this, right, the next question should be, why do you need to know if there's a bird in the picture? Is that really important to the problem? Is there a better way to get that information? Does it need to happen by machine learning or artificial intelligence, or can we do polling of the users? Right. So without the context, the engineer may actually go off and do exactly what you asked, and it might take 5 years to get it done. So giving that context will help them know how important the problem is and the best way to solve it. And fifth, it's not all features. So as product manager, you're going to be pushed to deliver features. Every interview question is, how do you craft a feature? How do you craft solutions to the big problems at hand? You may have seen Circles framework, and it's great, but it leaves out a lot of real world work that you should be aware of. And engineers have other types of work they need to think about as well, as do you. And so if you're only focused on cranking out new features, you're going to run into problems. So again, another analogy. Imagine this, you're a car manufacturer and you're building cars. So there's two major parties you need to think of. You, the car manufacturing company. And this is analogous to you and your product. You're building something that you're selling. And then the customer. And the work you do should benefit either you or the customer. And so how do you classify this work? And then I would argue that of these four things on here, only one of these is really feature work. But all of this type of work is actually needed when you're building a product. So how do you break these down and classify this? So I like to think about this different type of work, which is who benefits and what's the result. And so features are things that deliver more positive value to the customer. The customer gets something good when you build a feature. Defects, and in fact, they deliver less bad to the customer. So you're fixing a problem, you're removing a negative. You're not actually giving them something better, but you're taking away a problem. Tech debt, which we've all heard about, delivers positive value to you. It allows you to work faster or better or more efficiently. But working on tech debt doesn't directly give the customer anything. And then again, there's risk. And that's reducing the likelihood of something bad happening to you or reducing the impact of something bad happening. So much like hiring a security guard for a building, it doesn't remove the possibility of a robbery or a data breach, but it reduces the likelihood and or impact. And so I think everyone understands the value of working on new features. And I also think people understand why you need to put capacity towards fixing defects. But I think debt and risk might need a little bit of explaining. If you don't spend time on technical debt, you'll end up in a death spiral where you can't ever build any more stuff. This is what happened to Nokia with their phones. They never paid down their debt, and the cost to add new features was just too expensive. And if you're young and wondering, who's Nokia? Then that's just more proof that they failed to invest in paying down their debt, because now they're not even in the conversation of phones. And then finally, there's risk work. And this is things like getting SOC 2 Type 2 compliant, or getting GDPR compliant, or investing in secrets management so that if your if passwords leak, they're salted and you never have any problems. Your engineering team will tell you that they need time to work off defects, debts, and risk. Believe them. If you just push for features, you're going to have a bad time. So going back to a car analogy, and the things I was talking about. So how do these bits of work fit the classification? And I'll argue that a turbocharger gives the owner of the car more enjoyment of the car. They get to go faster and let the wind blow their hair and have a good time. Building an automated assembly line lets you build more cars faster. It's a benefit to you. It's not necessarily a benefit to the customer, but it's something that you want to do to make your business better. Recalls are like fixing defects, right? It's taking a problem away from the customer. And then complying with regulations as risk work. It minimizes the likelihood of lawsuits or data breaches or other things of that nature. I often find those are the hardest ones to classify, but it's good to think about this mix of work when you're trying to figure out what's our capacity and when will we be building the next set of features? Because oftentimes people want to front load all the features and forget about network, forget about risk work, and end up having debates over how much defects to deal with. So again, another obligatory XKCD to explain risk work. And so securing the emails and passwords is work to reduce the likelihood or impact of a bad thing happening. So let's, you don't want to be in this situation. All right, so to recap, you may have the vision, you may have the strategy, you may know what the most important problems to solve are, but without a good engineering team, you'll never get off the starting blocks. And I hope you'll be able to learn from some of my mistakes and become a better product manager because of it. So with that, if anyone has any questions, comments, please let me know. Thank you all very much.
Hey, Trevor, thanks. That was a really great talk. Really appreciated you getting in the weeds on how to work with engineers as an engineer myself. I do, wonder from product people, how often do they run into engineer or engineering managers on teams they work with? Engineering manager a really common person in an organization, or is that something that is missing in some organizations?
Are you asking me how often people have engineering managers, or just the audience?
Oh, either. I mean, if that's an insight on from you, great. It was a question for you, but we can leave.
Okay. From the companies I've seen, it's typically an engineering manager is something I have typically seen before. If not a pure engineering manager, at least like a team lead. So you might have a bit more of a player coach. And I've had that as well. Somebody who is trying to straddle both the engineering management side of the house and also doing a bit of development work as well. I find that can be, in a smaller company maybe, but I feel like sometimes if you're trying to be on both sides of the fence, right? If you're planning to be both the hummingbird and the elephant, that's a tough thing to balance, because you've got to have dedicated deep work time, but then also be able to jump into meetings and deal with, HR problems and fires and that sort of thing as well. So I feel like even if the places I've seen typically do have engineering managers, and if they don't, I would argue that they should. Did that answer the question, Michael?
Yeah, that did. Because I've not personally been in a lot of product organizations. I'm coming from product from a more R&D type of perspective. I was doing, hardware or, basic research kind of work, and then moved towards software and in kind of technical spaces. So,
Okay.
I'm coming at this from the outside as I'm learning.
Gotcha. Yeah, I think the places, if it's brand spanking new stuff and you're like, I'm not even sure we're going to find here, I could see potentially not having an engineering manager. But if you've got a commercial product selling and you're iterating on it, I would think you'd have more likely to have an engineering manager.
Yeah, if you imagine like a worst case scenario where the call center has got like a direct line to the engineering team.
Oh, geez.
Where they're just scrambling all the time after everybody's, wish list. So if you got to back out from that scenario, obviously an engineering manager has got to, really they should be pushing work on you. Like you've got to organize this work. You've got to prioritize this work.
Yep.
And communicate the value of this work.
Right.
Operations, call center, everybody's going to have things that they want. But I think a product manager's job is to make sure that you're doing work for the customer. And like you said, paying down your tech debt and meeting your other obligations.
I mean, that's a good point. That's exactly how I got into product management, was kind of being the guy that was out there taking the customer slings and arrows and kind of buffering buffering engineering.
Mm.
And so I wasn't, I was also the guy that was putting stuff on their plate, but I was also kind of shielding them from some of the stuff they absolutely didn't want to do.
Yeah, that's a really good point. And yeah, I think a good engineering, especially for someone who's fairly new into product, a good engineering manager can help you, can teach the value of that as well. Yeah.
Hey, Trevor, question here, and this isn't really about working with engineering as such, but I love the way that you talked about classifying the different types of work.
Mm-hmm.
And one of the challenges is when you're trying to prioritize, feature work against tech debt versus other, et cetera. I have some ideas around it, but I'm curious what your ideas are in terms of how do you prioritize when you have four things that are really quite different from each other.
Absolutely. So I'm not trying to pitch, but this is not a unique idea to me. The CEO of our company wrote a book about this, so it's easier to do that here because the company's bought into it. But effectively what we do is we set up a distribution. We say, we want to put X% of our capacity towards tech debt, some percentage of our capacity towards features, some percent towards risk, based upon what the objectives of the company and the product team are. And so, at different stages in a product's life cycle, that distribution should be different, right? So if you're trying to launch, you're not going to be spending a ton of time on debt. However, if you're more at the end of life, you're probably not spending a whole lot of time on features. And so we try to come up with a distribution. We socialize that with the company to say, look, here's what we want to do as a company, as a product development team. And so the best way to do that is to put this capacity towards features, this towards debt, this towards risk, and this towards defects. And then within those, you can then sort of figure out, well, what's the priority of the features within that slice? What's the priorities of the debt within that slice? And don't get me started on the, tech debt. There has to be some sort of payoff period. So I feel like tech debt is very analogous to financial debt. It accrues interest. It makes your current work more expensive. But if you let engineers just go and pay off any debt they want, they may spend a ton of the capacity on, well, I'm just going to go make this thing perfect. And like, well, great. You're going to spend a month on this. How long until I get that month back? Oh, well, you never will, right? Or it's going to take you a year. The payoff period is going to take, a year to 18 months. That's not the right debt to attack. So we just socialize what's the distribution of work, and then prioritize within that slice.
That would be the answer I would give too. Just wanted to hear it from another one.
Good. Glad to hear it.
Hey, by the way, what's the book? It's okay.
It's called. It's called Project the Product.
Oh, okay.
And so the idea is that for large enterprise companies, likely not a lot of people here, but for the Fortune 500 companies that are now figuring out they have to build software, a lot of them have been addressing software in the same fashion that they addressed projects.
Mm-hmm.
We're going to staff up a team. They're going to go build something for a year, and we're going to disband the team, and that thing is going to survive. And they fail to realize that products need continuous care and feeding. And you don't just staff up a team, build something, and release it, and then go elsewhere. You need constant investment and dealing with the tech debt and having a consistent team working on that product and not a rotating cast of characters. And surprisingly enough, a lot of these big automotive, insurance, banks, et cetera, are just now coming around to understanding that.
Yep. Yeah, no, I've done a couple engagements with several companies where it was the IT focus, and that's exactly what they were going
Yep.
through. And the challenge, of course, and it going to get a little off topic here, but is their funding models still
Yep.
are project oriented, and it takes a lot for them to really change their funding models too.
Yeah, a lot of these companies view IT because they're building a lot of internal tools. They're not a lot of the software that people we sell to are building internal tools, and they view IT as a cost center. They don't see it as a competitive advantage and a revenue generating endeavor. And so they're very, very tight with their money, and it makes it difficult for them to actually build good stuff. And then you have companies who are starting from the ground up, software companies who are coming in and taking over, and it's scaring the heck out of some of these big entrenched businesses.
Do you have time for a question?
Yeah.
Okay. Trevor, quick question. I like your discussion with Tom on one of the aspects that I keep hitting over and over is I keep seeing that where super sharp developers are making strong arguments for refactoring, fixing things up before it becomes too complex to add new features. House of cards syndrome. What are some arguments that you use to align their thinking with kind of the overall goal of the product, some sort of metrics that says, okay, tell me in terms of user benefits, how is this refactoring, how is this paying this technical debt going to help the end goal?
Right.
Kind of hard to argue that.
It is. So the trick is to turn it away from, to get the engineers to stop thinking about themselves, which again, I know we all think about ourselves.
It's like
but you have to say,
craft,
right?
But you can craft all day forever.
Right, and it's that there has to be like, what does the end user get out of this? And if you keep asking, why do you want to do this, you'll eventually get there. I've had this conversation with my engineering manager just a few weeks ago. We're coming up with a big roadmap of like, we have the features we want to do, but now it's like the deep, dark technical roadmap that we want to achieve as well. And we're thinking about that as a first class thing. And she kept saying, well, I want to do this. And I kept saying, why? And it's, well, because it'll make it easier to scale the team. Why? And eventually you'll get to, because it'll make customers happier, or because we'll be able to deliver more value faster. And if I found that if I just kept asking why with the right framework, the right state of mind, and in a collaborative fashion, that seemed to do a lot of good to get us there. And it often thinking about this and what's the payoff period? So if I invest a month of work to make this technical problem better, there's a reason for that. Either I'm going to reduce the number of defects, and it's going to, by reducing the defects, I'm spending less time on fixing problems down the road. I'll be able to get more value to the customer. I'll be able to, or it'll be easier to build out new features, and therefore I can get more value out to the customers faster. And
Right.
So trying to think about what's that payoff period. If it's going to take me 6 months to make something better, but the payoff period is 3 years, that's probably too long, right? If I can spend 2 weeks on something, but I'm going to see that payoff period in 6 weeks, probably a bit better.
Like for example, the code coverage metric has been a decent point of alignment. Like if we drop from 80% to 60%, maybe okay, it's worth to catch up. Are there some metrics like that you like to put in your dashboard that is simple to align and kind of cuts back on this endless loop of conversations?
No, I'm sorry. Say that part again.
Like the code coverage metric.
Oh, code coverage. Okay.
Has been kind of a simple number where you can kind of align, right? If it's less than 80%, okay, let's slow down for a bit, catch up.
Yeah.
Moving. I have simple metrics like that you can put on the dashboard and cuts back on a bunch of arguing.
Not exactly. So the things that we try to deal with is the number of, we're tracking like a number of escape defects. We're tracking what we're calling code reds, which are like not just a regular defect, but a severe customer impacting thing that we have to jump on right away. And other incidents. And if we notice that those start going up, then we realize we need to take a step back and put more of our distribution, our work distribution, towards either paying off those defects or trying to figure out what's the root cause of them. And if that turns out to be, we need to spend more time on tech debt, then so be it. Yeah.
Thank you.
Yeah.